Today we'll create a transient nonlinear plastic analysis of a coupon, then we'll release the enforced displacement constraint to see how much it springs back. We'll begin by creating a multi-step nonlinear solution 402 analysis with large strain and material nonlinearity on under the Parameters tab. Then we'll create a nonlinear static subcase where we'll select an end time of 1.3 seconds with 65 increments. Next we'll create a brick mesh on our coupon. Then we'll assign a material that has a stress-strain curve. And the only one in the library that has that is steel rolled, so we'll select that. Next we'll create a fixed translation constraint on the bottom face. And we'll create our enforced displacement constraint on the top face. Here we'll pull our coupon with an enforced displacement defined by a field. The independent domain will be time. And we'll begin at 0 seconds with a 0 enforced displacement. And then we'll go up to 1 second where we'll have our full enforced displacement of 1/10 of an inch. We need to maintain that 1/10 of an inch for some amount of time until the end of our field, which we'll define at 1.2 seconds. After 1.2 seconds, the enforced displacement will be released and we'll see that spring back after 1.2 seconds to the 1.3 seconds that we had for a total time of our simulation. And here I've paused the video while it's solved. It runs in a little under a minute, and then we can view our results. So let's take a look at our last time step. Here we can see that spring back. Because we pulled it with 1/10 of an inch, it sprung back to 93 thousandths. We can animate those results across time, or we can also plot them across time. So here we can see our plot of the displacement at the end of the coupon as a function of time. And if we want, we can probe to see exactly what that displacement is after we've released the enforced displacement and see what that spring back is. And that's how to release an enforced displacement constraint in a transient nonlinear plastic analysis to see how much the part springs back after the load is released.